So as I was telling that AlexNet, by just looking at the name, it seems that it is a gadget, a tool, or a device, but it is simply a type of CNN, a type of convolutional neural network. And the name AlexNet has been given in the name of the person who actually designed it and proposed it. This name has been given in that person's name. So that person was Alex itself, Alex, Alex. Full name was Alex Krizesvi. Okay, so it's difficult to pronounce. So I'll just write it for you. So it is KRI, then ZH, Kriz, and then it is EVSKY. Okay, so this is the person's name who actually came up with this neural network, and he was the winner of the competition. So he was winner of, the short form is ILSVRC, which is a competition which is IMAGE large scale visual recognition challenge. Okay, so this is large. So ImageNet large scale visual recognition challenge. So this happened in 2012, and he was winner in that particular. He was, in the sense, his network was winner, and that is named as AlexNet. So winner in the sense, out of one of the winners, like there are multiple winners, but he was one of them. Now, what are the important features of this AlexNet? So let me just mention them to you. So FEATURES, features of ALEX, AlexNet. And then you will be easily able to understand that what exactly is it. And the way we created like 2-3 neural networks from morning we have been creating. So similar way, this also has to be created the same way. Okay. Now in this particular case, this model, okay, has to train 60 million parameters. Okay. So you can just imagine, okay, 60 million parameters. And the challenge is the model is PRONE, prone to OVERFITTING, overfitting. Those who are new, overfitting, there are three terms, like overfitting is there, underfitting is there, and then there is an appropriate or best fitting. Okay. So overfitting is that when we have a model and model is learning from the data, at that particular point of time, model learns the data from the data so much that it only gives correct output for the same data. So for example, let's say if we teach a small kid A for apple, B for ball. So we have taught him just for A, B, C, D. So the child is only going to tell correct answers for A, B, C, D, and they're always going to be correct. But the child is always going to give you the wrong answer for anything apart from A, B, C, D. This is called as overfitting. So overfitting is, on the same data, it is going to give perfect, wonderful output. But anything else you ask, okay, like small kids do rectification, they will just tell those questions, answer to those questions. They won't tell anything else apart from that. That is overfitting. Underfitting is the child cannot answer anything. Even if the child is answering, the answer is random. Completely random. There is no logic, no sense. That is underfitting. Okay. So we actually want best fitting. That whatever the child is learning, and whenever some new situation comes in all the cases, the child should be able to handle and manage. That is what is best fitting. So here, the challenge is that the model is prone to overfitting. Okay, so what to do now? There is a technique. Okay, I'll introduce that technique to you. There is a technique which is called as dropout. You can basically name it as dropout layer itself. Let me help you with this particular technique. What exactly is dropout? And for that, let me take some diagram from the previous ones. Hmm. I'm taking the same diagrams from here. So now understand what happens. These are different layers. I'm taking these from there only. Yeah, look at these. Now what happens in dropout? Let's say we have certain more. So while going to the next layer, what is going to happen? So in dropout, what happens? We have, you can see 1, 2, 3, 4, 5, 6. 6 nodes are there. So all the 6 won't participate. Okay, all the 6 would not participate. So here we have 6, and let's say here also we have some more layers. Okay, and let's say there are 5. So 5 layers. Dropout layers, and then 3 layers are there. So dropout is going to cancel out some of the layers itself, some of the nodes. This is getting cancelled out. So this one is getting cancelled out. Okay. Let's say this one is also getting cancelled out. You can see that in this particular layer, those 2 nodes got cancelled out. In the next layer, that one got cancelled out, and this one got cancelled out. This is called as dropout. When you are facing a problem of overfitting, then you can stop some of the nodes to learn from the data, and if they are not learning, that means they are not going into overfitting. Overfitting is overlearning, actually. Overlearning. You learn the data so much that you just tell everything about data only, nothing else. It is overfitting. So you can control the overfitting by dropping out some of the nodes from a particular layer, right? So this is something you can do. So here let me write drop. So 0.5. So with a value of 0.5. Okay, so 0.5% of the 5% of the nodes will get drop out. If we have total 100 nodes, then basically 5 out of 100 will not participate for learning purpose. So that is what is happening. So this happens in the first and second layers. So when we are designing a CNN, if that CNN is AlexNet, then we will have first and second layers where we will have a dropout with 0.5% dropout. We will set those layers. Okay. And these are fully connected layers. So that also let me mention. Dense layers which we use, these are fully connected. Okay. The next part was, so you can see that dropout is an important feature. Dropout happens in first and second, and they are fully connected layers. That is important. Then it has got to train 60 million parameters. That is important. That it is so huge a number. And the next part is, yeah. So the next part is activation function. Activation function. So ReLU is the activation function which is used. Okay. So what we are discussing here is something which Alex, that person, has already designed. So we are just discussing that what he designed and how basically he was among the winners. Okay. So activation function was ReLU. ReLU activation function he had used, and so you know that we have sigmoid, tanh or anything else. So he used ReLU. Okay. ReLU helped to achieve the um, faster training was happening because of Relu. That was his observation. Okay. So certain features which basically he made use of. Now let us move ahead and try to work more on it. The design architecture of AlexNet. So how it was designed. Okay. So design wise, it has got five convolutional layers. Okay, so this is one major point, that it has got five convolutional layers. Okay, an important part. Then next thing is first layer, the second layer, and the fifth layer. So first, second, and fifth, it has got max pooling layer. Introduced you about max pooling layer. So first, second, and fifth, it has max pooling layer, and the purpose we know is feature extraction. That is the purpose of this max pooling layer, feature extraction. Now moving ahead. So after that, other properties of this max pooling layer was filter size as 3 by 3, then wide of 2. So filter size is 3 by 3 and stride is 2 here, and this basically helped in reducing the error rate. So all these are observations. Okay, error rates, so which came as top 1 as 0.4 and top 5 as 0.3. Rate to 0.4 and 0.3%. That much reduction we were able to achieve. Okay, so total 5. So now we will design, and we will design the way we have coded in previous case. That way only we will design. But what we will do, we will have first, second, and fifth as max pooling layer, and then filter size we will have 3 by 3. Stride we will have 2. So these settings we will do. Okay. Then we will have two fully connected layers. Okay. Then we will have two fully connected layers, and again with dropouts. We'll have dropouts also. Okay. For prediction, so prediction will be made by softmax function. Okay. So final prediction will be made by softmax function. This is how the whole design would be there. So I hope you are able to understand this, that AlexNet is nothing but it is a special type of CNN designed by the person named as Alex himself, and which became very popular because it was one of the winners in the competition with very low error rate or very high accuracy. That is the reason why it became so popular. Okay, so let me help you with the AlexNet design, AlexNet, I will say architecture. So the AlexNet architecture we have is the same thing I'm drawing over here. Okay, so we have the input image over here. Consider this as input image. Okay, so input image is there, and after input image, we know that what is the first layer. Let me have it like this. So the first layer we have is conv1, conv1, convolutional layer, convolutional layer. After conv layer, then next we have is max pooling layer, as I mentioned. So this is max pool 1, max pooling layer. Okay, so max pool 1. Then after that, we have again one more convolutional and again one more max pooling. So let me create a duplicate of them and arrange them in the same manner. So this is conv2, this is max pool 2. Done. Okay. So input image, we have convolutional layer, max pooling layer, then again convolutional layer, again one more max pooling layer. Okay. So we have these four. After that, we have multiple convolutional layers itself. So I'm taking this one, and so this would be conv 3, right? This would be conv 4. This would be conv 5. Okay. Then what else? So I think I'll have to just reduce the size of this. Let me reduce, and then I'll have to bring all of them. Again, all of these. So these many layers we have. One more max pooling I will put. Okay, so that I'll put after this. This third max pooling. So yes, and after that we will have two fully connected, and then for output purpose softmax. So three more layers, and I believe we'll have to string all of them. So let me do that. Yeah. So yes, now here you can see. So these are fully connected. FULLY fully. CONNECTED connected. Let me name it as 1. So here you can see fully connected 2. And the last one is softmax. Okay, now I believe the whole AlexNet architecture is in front of you. The whole AlexNet architecture. So it's a special type, the way you create a neural network. Okay, that is a CNN type. So it is just a special kind of it. Okay, nothing different.